Hello everyone! It's me again, Teacher Joanne. This tutorial is for statistics and probability, a subject which is intended for grade 11 senior high school students in the Philippines. So for today's objectives, at the end of the lesson, the learners will be able to identify the sampling distribution of statistics or the sample mean, finds the mean and variance of the sampling distribution of the sample mean, defines the sampling distribution of the sample mean for normal population when the variance is known and unknown. For today's topic, we have the mean and variance of sampling distribution. So sampling. So from our previous lesson, we have defined what is sampling. So it is a process of selecting respondents from the population. So we have two types. You have the probability sampling and non-probability sampling. So for probability sampling, so samples are selected in such a way that it will represent the whole population. They provide the most valid or credible results because they reflect the characteristics of the population from which they are selected. So example is a simple random sampling, stratified random sampling, systematic sampling, and cluster sampling. For non-probability sampling, so non-probability sampling is also sometimes called non-representative sampling. Non-probability samples are less efficient than probability sampling. So bakit? So bakit siya less efficient? Kasi it doesn't represent the whole population because you are only taking samples based on some characteristics. Okay, so example of non-probability sampling is convenience sampling and purposive sampling. Next, we have sampling distribution. So what is a sampling distribution? So it is a distribution of the possible values of a statistic for a given sample size n selected from a population. So its objective is to find out how the sample mean varies from sample to sample. In other words, we want to find out the sampling distribution of the sample mean. So the mean of the sampling distribution is equal to the mean of the population. So given by the formula, so sample mean is equal to the population mean, which is also equal to the expected value. So the formula is 1 over the total population times the summation of the sample, or summation of the sample, or x, divided by the total population. The standard error of the sampling distribution is determined by the standard deviation of the population. So here's the formula. So the standard deviation of the sample is equal to the population standard deviation divided by the square root of the sample size multiplied by the square root of the population size minus the sample size divided by population size minus 1. So, for example, so a population of n equals 4 senior high school students are aged 16, 18, 20, and 22. Define x as the age of the individuals. So, find or determine the population mean and population standard deviation. Number 2, develop sampling distribution of n equals 2. Construct the histogram of the sampling distribution and determine the expected value and variance of the sampling distribution. So first, we compute for the population mean and the population standard deviation. So for our formula, so we have 1 over n times the summation of the samples. So let's substitute. So we have age 16 plus 18 plus 20 plus 22, and then we have the population size, which is 4. So divided by 4, we have the mean equals 19. For the standard deviation, we have the formula square root of the summation of x minus mean squared divided by n. To substitute, so we have 16 minus 19 squared plus 18 minus 19 squared plus 20 minus 19 squared plus 22 minus 19 squared divided by 4, and then get the square root of the answer. It will give us 2.236. Next, for number 2, develop a sampling distribution of n equals 2. So first, let's solve with replacement. So since we are having a sample of 2, we can make a table representing the ordered pairs and their mean. So first, we have the table for the ordered pairs. So we can make a matrix. So we have the ages on the first observation, so as with the second observation. And then we pair the two. So we have the pairs on the table. And then we get the mean for each of the pairs. So for the first observation, second observation, just get the mean of the pairs. So we have the results on the table. Okay, so we just copy the table from earlier. Now we can solve for the mean. So same formula. So 1 over n times the summation of x. So just substitute. So if you look into the table, so there is only 116, 17 is 2, 18 is 3, 19 is 4, 20 is 3, 21 is 2, and 22 is 1. Okay, so just substitute that. So 16 plus 17 times 2 plus 18 times 3 plus 19 times 4 plus 20 times 3 plus 21 times 2 plus 22. And for the results of the mean, that is 16. So divided by 16. And it would give us the same answer for number 1, which is 19. So as we defined earlier, so it says that the sample mean and the population mean are equal. So we have an alternative solution if you recall for the formula of the expected value, which is for the sample. So that would be summation of x times the probability of x. So we can make a table for that. So we have the sample mean and then the probability. So sample mean is the mean we have on our table. So 16, 17, 18, 19, 20, 21, and 22. And for the probability, so over 16, so there's only 116, so we have 1 over 16 and so on. And then we can just substitute using the formula. So we'll have 16 times 1 over 16 plus 17 times 2 over 16 plus 18 times 3 over 16 plus 19 times 4 over 16 plus 20 times 3 over 16 plus 21 times 2 over 16 plus 22 times 1 over 16. And the answer is still the same, which is 19. Then to solve for the sample standard deviation, we have the formula population standard deviation divided by the square root of n. So substituting, so earlier we have computed our population standard deviation, which is 2.236, and then divided by the square root of 2, which will give us 1.58. So next, we compute without replacement. So since we're still having sample of 2, we can still make the table for the ordered pairs and their mean. So here's how it looks like. So we cannot have 16 and 16 since this is without replacement, meaning that two numbers cannot be repeated. So we only have 16 and 18, 16 and 20, 16 and 22, 18 and 20, 18 and 22, and then we have 20 and 22. And for their mean, so here's how it looks like. So for 17, we have 1, have 118 also, 19 is 2, and 20 is 1, and 21 is also 1. Okay, so we just copy the table and then we can solve for the, again, for the mean. So same formula, and then we just substitute the values. So 17 plus 18 plus 19 times 2 plus 20 plus 21 divided by 6, and it would have the same answer for the mean with or without replacement. And so we can also have an alternative solution, same thing with the expected value. So we would have the table here, and the substitute, we have 17 times 1 over 6 plus 18 times 1 over 6 plus 19 times 2 over 6 plus 20 times 1 over 6 plus 21 times 1 over 6, and same thing, the answer is also 19. And for the standard deviation of the sample, so we would be using the formula for the standard error. So we have the population standard deviation divided by the square root of the sample times the square root of the population minus the sample divided by the population size minus 1. So to substitute, so we have the population standard deviation is 2.236, then divided by square root of 2, multiplied by the square root of 4 minus 2 divided by 4 minus 1. So it will give us the sample standard deviation of 1.29. So for number 3, it asks to construct the histogram of the sampling distribution. So we have two histogram. We have with replacement and the other one is without replacement. So this is how the histogram look like for with replacement, and for without replacement it looks like this. So if you would notice, for with replacement, the distribution looks normal. And for the other one, so for the probability of 17, 18, 20, and 21, it has the same. And the one that has the highest probability is 19, which is 2 over 6. So next, for number 4, we are asked to determine the expected value and the variance of the sampling distribution. So for the expected value or the sample mean, we have computed earlier. So same thing as the population mean, which is 19. And for the variance, so if we recall the definition, so we just have to square the standard deviation to get the variance. So we have the population standard deviation as computed earlier is 2.236, and if we square that, it would give us the variance is 5. So just to get the sample variance, so we have a formula. So the variance of the population divided by the sample size. So we have 5 and divided by 2. So we would have the sample variance is 2.5. That is for with replacement. So the standard deviation with replacement as we computed is 1.58. So if we square that, it would also give us the variance which is 2.5. So same thing as we have computed earlier. So for without replacement, it is 1.29 as we computed from the previous numbers. So it will give us a variance of 1.67 if we square 1.29. But just to use the formula, so we will have the variance of the of the sample equals the variance of the population divided by the sample size multiplied by the population size minus the sample size divided by the population size minus 1. Then to substitute, so we have 5 over 2 times the quantity 4 minus 2 divided by 4 minus 1, and it will give us 1.67. So that's for without replacement. So same thing as we did when we squared the 1.29 computed standard deviation for the without replacement. So we're done for today, and thank you very much. I hope you learned a lot today. See you in our next lesson. Bye!